the question from last week meeting. One student has not answered it yet. This one from Eka. Mbak Eka sudah hadir? Okay. The students that has questions not yet come yet.
Oh, okay.
Okay, we wait. Dr.
Yeah,
Mages.
yeah. So actually, when I saw the connection is not, I got distracted. I got worried. Actually, that's why about 11:15 until I think I just got the connection. Totally, I didn't have.
Oh, yeah. But
So,
yeah, sometimes it happens. Okay, no problem.
Right.
Yeah. All right. Now we have already 9, so it should be one more student. Mbak Eka diingatkan nggih, Mbak Maria? Yeah.
Yeah, Dr. Nurma, since we have some time while waiting for the student, I also thinking maybe we can sign I'm not sure whether it's called MOU
or MOA.
MOA, yeah. I'm not. Maybe we should go ahead. I will find out from the university what we should do, whether it's MOU or MOA. And there's also something called what is that? Memorandum of research collaboration or something like that, So I will work on it. So maybe we can start signing, and maybe that can carry some KPI value as well.
Yeah, we have the same frequency. I just want to talk about this.
Okay.
Yeah, okay. So we can follow USM template or 11 Maret template. We can flexible on it. So just let me know which one is better for USM. And
I will speak to the responsible person and then I get back to you.
Okay.
Right.
Yes. All right. And also we plan to have the research collaboration regarding this misconception, I think, and then green chemistry, because you are the expert, right? Hopefully I can also do something with green chemistry, and then we can do it collaboratively.
Yeah. And perhaps something on STEM as well. So because now everybody is talking on STEM. So I'm also working quite heavily on STEM. Currently I have 3 research grants where I'm leading on STEM education.
Oh, yeah. The same as here. That's I asked you in our Zoom meeting, how about teacher professional development in Malaysia regarding STEM teachers? And
as I said, there's no explicitly on STEM, but during the teaching we integrate STEM.
Yeah.
So that's what we are happening. And also I'm hoping we can come out with some papers, out of this collaboration. Maybe some of your students are working on it. I'm not sure whether I mentioned this to you or not. Regarding our special issue for there's one journal by the name of APG, Asia Pacific Journal of Education and Educator. It's a. Did I mention that to you?
You mentioned about the journal, but not the special issue.
Oh, okay. Yeah. So I am actually editing a special issue. The special issue will be published in December next year.
Okay.
Next year, December. So maybe you can ask because that one I cannot have my name there because I am the editor. It's not appropriate my paper to be there. So you can work with your students. Maybe you can come out to 1 or 2 papers, maybe 2 papers. I can try to put the paper in my article inside because the theme will be very specific on chemistry education.
Oh, okay. So I will take a look. There is an announcement about special issue in the journal APG, right?
Yeah. Once I prepared the brochure, I will share with you. I've not done yet. Actually, by right, I should have done, but I'm so busy with so many things. I'm not done yet.
Because you also have a class with Dr. Tusi, right?
And then I have my own, our semester begin ready. So last week was our first lecture. So it's like too many things in my plate, and my teaching is, my teaching is not much actually. My teaching is in university is not really much. I handle the research method course in the university, but I have a very large group of students, PhD students. So that actually drains me off. So,
yeah,
sure that's the thing.
You have that problem.
Yeah,
and then now approaching the end of the year, you know,
so many things.
Things report, and yes, all of the things.
Right.
Yeah. Okay. Any my students today, Agama, Maria, Fatwa, would you like to say hello first to Dr. Marquez? Please, you can say hello first to make you smile and then make her have more spirit today. Please, you can say hello to her.
Hello, hi.
Hello, Dr. Marquez.
Yeah, hi.
Hello.
Maria, is it? This Maria? Yeah, I can see her name. Hi.
Maria is in Nusa Tenggara, ya, Maria, ya? In Southeast Sumbawa, the islands in the east part of Indonesia.
Oh, okay.
Yeah. We are in Java, and Maria is still there because we have online learning. Okay, good. Right. Okay, Dr. Marquez, we will start now. Now already 11:09. Thank you very much again. We are very happy and excited to have you again in the second meeting of our visiting professor class program in terms of misconception in chemistry. And you have 100 minutes to go from now on to, we can discuss regarding your plan to, we want to learn about the instrument to diagnose the misconception that you mentioned in the last week. But before that, I'm sure although Eka is not come yet, maybe we can start with the answer from Eka's questions from last week.
Okay.
Yeah. So the question I wrote in the chat box, is about misconception, adalah ketidaksesuaian pemahaman dengan kesepakatan ilmiah yang dirumuskan oleh ilmuwan. Miskonsepsi ini dapat terjadi pada pendidik atau peserta didik. She asked about strategy to reduce or eradicate the misconception. So you can you will start to this is a general question.
Yeah. So maybe Ika, if she follows the lesson today, I will introduce a few instrument. Today is only a diagnostic test, or you can call it instrument. And then I will touch on conceptual change model, which is a very popular model by Posner, whereby when you apply this model, there are high possibility for us to reduce the misconception. But to totally overcome the misconception, it's quite impossible. But we can reduce the misconception. So I will introduce the model. So today I'll talk about the instrument and also the model. Next week, I will share with you some of our own intervention and also from the literature, whereby we have developed teaching based on the model, CCM, conceptual change model, whereby we identify that the teaching has been effective to reduce the misconception. So that will be the large part for next week. But this week I'll touch on the instrument, because the instrument also, I think it will take quite some time, and I have to shift between PowerPoint and words and PDF, because it's so difficult for me to really show the instrument in PowerPoint slide. So I will be shifting on that. So I hope nothing happens, because I really worried when we use the online mode, or, we can expect many things.
Sometimes in my building also not stable, the connection.
Right. You know, even the sharing one, I stop this one, I take another, then that suddenly the document disappear, and you know, all these things I have experienced. So I hope all that won't happen for today. We can go on smoothly.
Yeah.
Okay. So let me share the PowerPoint first. Okay, can you see the PowerPoint?
Yes, that's PowerPoint. We can see it clearly.
Okay.
Hold
on. Okay. So now today's lecture, I will be talking about diagnostic and instrument and CCM. Before that, very good afternoon to all of you. Good morning in Indonesia. Over here it's already 12 o'clock. So very good morning. And then thank you for staying with me from last week and continue with this week. I hope you will sustain your motivation to stay ahead for another 2 weeks, you know. And I hope you are learning from the session rather than just listening. I hope you are learning as well, and I would happy to see some of the outcome from you. So probably if you already have an idea, you can draft in a brief manner, then you can share with me. Okay, so let's start with a very basic way of diagnostic. What you call that? The misconception. At the same time, you can actually overcome the misconception using concept cartoons. So this is one of the work that my students have done. So I will show you 2 examples, which is done with primary school students, but it is also appropriate to conduct with secondary school or secondary school students or high school students. But the one I'm sharing with you, we have done with a primary school student. So this is very interesting. That's why I thought of I want to share with you. So the first approach is concept cartoons. So this concept, we have used this concept to identify the misconception. We detect the misconception. At the same time, we manage to address the misconception using the cartoon. Okay, so why we used cartoon? Because in the cartoon concept was first introduced by this person, Keogh and Naylor, in 1999. So following his work, we thought there are many positive feedback on using cartoon concept. So mainly the positive feedback are study says that it can structure students' idea. So maybe the student's idea is something not in a proper manner. So once watching or looking at the cartoon pictures, they manage to restructure the idea in a proper flow. So some studies also said it promoted positive attitudes towards science teaching and learning, normally among young children. Okay, and it also said that it managed to uncover the misconception and also remedy the misconception. So this is the reason why we thought of using the cartoon concept. And besides misconception, cartoon concept also, when you engage students in discussing about the cartoon concepts, it engages them in higher order thinking skills. You know, it really makes them more creative. You know, they really makes them to be critical in their thinking, in stating their ideas. Okay, so and the learning environment also, when you give something like this, the students tend to participate in the learning. They engage in the classroom rather than passive way of listening to the teacher. They really join in the teaching and learning. They want to say something. They always have something to say. So that actually makes the classroom very lively and very motivating. Okay, so how we use the concept cartoon. So I show you one example. So this is the concept that we have got it from somewhere. I can't remember where we have got this thing from. We post these pictures to the students. This is the lesson during the objective of the lesson is to teach about photosynthesis, okay, for the primary school student. So the first objective of the lesson on photosynthesis is food sources of plants. So what are the sources of food? What plants actually, what kind of food actually plants consume? That is our aim of the lesson. So rather than just simply teaching the ordinary way, we thought of doing in this way. So if you look here, we have showed this picture to the student. What the teacher did was she printed the picture. She grouped the students 4 or 5 in a small group, and then she gave each group these 2 pictures. So what the students have to do is they need to observe the picture. Okay, they need to observe the picture, and then from there they need to identify what kind of information they can actually extract from the picture. So it's not that the teacher leaves to them, but the teacher continue asking questions. Like for example, this is the narrative of the teaching and learning that went on during the lesson on photosynthesis. So the teacher said, what is your answer to the question, what are the food sources of the plants? So there is a question. If you see the picture, this is a food sources of plant, and many students are giving different answers. Okay, so when the teacher asks, so M2 is a student with a misconception. So when I analyze the interview, it's not an interview responses, it's a video observation, utterances. So this is what I get. So one of the students said, oh, it's fertilizer. The student said, it's fertilizer. So since fertilizer is an incorrect answer, I just label it as M2, misconception 2. Misconception from student 2. Okay, then the teacher continue asking, why do you think so? M2 said, because when we add fertilizers to the soil, the plant can grow. So students are having misconception that fertilizer is the source of food for plants. But is it the food for the plants? M said, and M2 said, yes, it is, because the plant can grow. Do you think it's correct? I think fertilizers are food. So even though the teacher tried to prompt the students with more question and try to really get deeper insights, but still the student is thinking fertilizer is food. Then the teacher asks, who agrees with this answer? No response. Who disagrees with this answer? Many raised their hands. That means in the class, there are some people disagree that fertilizer is a food, right? So the teacher asks, why do you think his answer is wrong? Okay, because fertilizers are not food. They can only make plants grow better. Okay, if fertilizers are not food, then what are the foods of the plants? M3 and M8. There's a different student, M3 and M8. So this is student 3 and student 8. Both these students are having misconception as well. They said food is made by plants themselves from sunlight, water, and carbon dioxide. So this one looks better than fertilizer, right? The answer seems to be better than fertilizer. It reflects that these students have some idea about the food source for plants. So they are saying sunlight, water, and carbon dioxide. But still, it is not correct. Still, there is some kind of misconception, right? So teacher continue asking, okay, then are sunlight, water, carbon dioxide? Many responded with yes and no. They are not the food for the plants, but the things the plants need to produce food. So another student, C is the correct answer. Okay, correct answer. This student says that sunlight, water, and carbon dioxide, they are not food, but actually they are substance required to make food. When we look at this answer, at once we will think it's correct one. Sunlight, water, and food, carbon dioxide, but actually they are not food. It is actually starting materials to produce glucose for food, right? So the teacher continue asking. So from here, you can see that there are many misconceptions. So you see someone here say M4. So soil is not a food for plants, M4. Then M5. They keep talking, the discussion, managed to extract many different types of misconception. Okay, so cartoon concepts is one way of identifying misconception. Just ask them, the students, to observe the diagrams or the pictures, and from there you can actually extract many misconceptions. So this is in-class discussion. So the communication is not over here. So the discussion went on very lengthy, maybe for I was if I can remember well, it went up to 1 hour, a very lengthy discussion. Okay, so after that discussion, the teacher interviewed them. So the teacher interviewed them. So what actually learned from the concepts, the cartoon concepts, and the discussion that went on in the classroom. So the student with M1, the misconception. I used to think that vitamins are the food for the plants, but it seems that I was wrong. Vitamins only help the plant to grow. It was not food for the plant. The plants are actually produce their own food. So the discussion itself managed to overcome the misconception. So this student M1 initially had misconception. So this M1 was thinking that vitamin is a food for plant. Then when did you realize that you were wrong? Okay, I realized my mistake after listening to my friends during the discussion. But both vitamins and fertilizers are not food for the plants. They only help the plants to grow better. So during the discussion, M1 got the idea that whatever he has is incorrect. Now M2, all the while I thought fertilizers are food. So the teacher continued asking, when did you realize it? So the student said, during the discussion, looking at the picture. Okay, then another M4 said, after listening to C1 and C4 during discussion. So that means C1 and C4 is the students with correct conception. So what I'm trying to say is, with cartoon concepts, you can actually identify misconception, and also you can address the misconception, but you cannot eradicate. You cannot totally overcome the misconception. You can only reduce the misconception. So this is one way of identifying and reducing the misconception. So maybe it works for primary school students, or maybe lower secondary school students. It's a good way of teaching, right? So one approach. Another approach is drawing. Drawing is also a very good way of identifying misconception among young learners. Okay, so why? Because sometimes when you ask students to explain, or when you ask students to write, they might not be able to express the whole thoughts in their mind into words. But if you ask them, give them an opportunity to draw, they might be able to express themselves. Pictures, in the form of pictures, in the form of pictures, diagram, graphs, and so on. Adult students, you can ask them to draw graph and all that, right? So when the drawing is incorrect, you can actually identify the misconception. Okay, so this is actually from course. I forgot to put that. I got the idea from course. So so another thing is, when we were trying to, when in the classroom, when you teach in the classroom, we always want to say things which are scientifically correct. Okay, scientifically correct. You are using a lot of words, as a teacher, we use a lot of words, to try our best to match whatever the students' thoughts, the thoughts they have in their mind with the scientifically accepted thoughts. So we try to match. But whatever it is, because of the wording, which is too much of words, younger age students probably would not be able to link with whatever we are saying, or whatever has been said has been accepted scientifically correct. But if you use a diagram or picture, that will be the best. Okay, so let's see how people have used it. So I used in the context of misconception on a water cycle. So we want to detect what kind of misconception students carries about water cycle. So this is misconception that we have found in the literature, and at the same time we have also found in our own research. So we found that water cycle is formed when the water from the sea is absorbed by sun and changed into rain. So it's not necessary from the sea alone. It can happen anywhere as long as there is a pool of water. So only evaporation and condensation process. So some students only think evaporation and condensation. So they are not aware of other processes. So when there is no sun, evaporation does not happen. So they think when the sun is, if at night evaporation do not happen because there's no sun. So evaporation only happens from the seawater. So this is incorrect. It happens in all the water, and some things it only happens at the water surface, at the surface, on the top of the water, the surface of the water, but actually it happens throughout the water. So these are some misconceptions that actually we have found out about the water cycle. Now please remember one or two of these things, then I'll show you. Now we ask the student to draw the picture of water cycle. Before we ask them to draw, there is actually this thing happened twice. One is before the treatment, so they already have some idea about melting, freezing, evaporation, condensation, because all this they have learned prior at the primary level. So we did this at the lower secondary, 12 and 13 years old students. So they already have some idea about the processes, but we are not sure whether they know completely about water cycle connecting all these processes. So what we did was we asked them to draw. So based on the drawing, we classify the drawing. The level 1 students are no drawing. They just give us back a blank sheet of paper. They are unable to draw. The level 2 is drawing with representational, non-representational. That means they have some drawing, but does not really reflects on the water cycle. They have some elements of photosynthesis. This is supposed to be water cycle. Some elements of water cycle. Okay, water cycle. But it's not complete. Level 3 drawings is misconception. They have some, they have labeled and everything, but there are a lot of misconception. I'll show you some examples. Partial drawing. That means the drawing are partially correct. They have no misconception. There are there's nothing wrong with the drawing, but their drawing is not complete. Level 5 is comprehensive representation drawing. So that means the drawing is complete with all the process of water cycle. Okay, so this level 5 students, the students which produce drawing which can classify as level 5, shows a sound understanding, a good understanding of water cycle. Okay, let's see. Now look at this drawing. So the level 1 no drawing means I'm not going to show you because when we asked them to draw, they didn't draw anything. They just give us an empty piece of paper back. They write the name and give us back. For the level 2, you can see here one of the example here. The student give us back this drawing. Okay, this drawing. Now you see here, non-representational drawing. The drawings include identifiable elements of water cycle. Also, the answers that included diagrams, formulation instead of drawing were evaluated in this category. That means they have drawn the sun, they have clouds, atmosphere. This is birds. So there's some kind of they have this understanding. Water cycle got to do with sun. You have clouds. It happens in atmosphere. And then you have living things, which is birds. But we can't actually make meaning of what they are trying to say. But the students have some idea. So this is called non-representational drawing. We can't really make meaning. We look at the diagram many times also, we don't understand what they are trying to say. So this is non-representational drawing. We go to this one. This one is misconception. This is the best I can really show you. I can't really make it bigger. Now, what is the misconception here? You see here, this one looks like the sea, clouds, sun. They have trees here. Okay, so there are elements of water cycle, which is sun, clouds, sea, some living things, you know, but incomplete, right? But incomplete. The misconception is water evaporates from and forms the cloud. So they're telling that we assume from the drawing we can conclude that, I don't want to use the word assume, and it becomes incorrect. We can conclude that the water is evaporated from the surface of the sea. You see, it is only from the surface. So this is one of the misconception. Water evaporates from the surface of the sea to form the cloud. So this is one of the misconception. And then it only talk about condensation. And it actually talk about condensation, and then actually it is labeled incorrectly. So the word here is said condensation, but then it shows evaporation. Water is evaporated. The wording here is condensation. Then the elements of water cycle is not complete. So example of drawings with misconception. So this is one example that I want to show. There are many drawings that we got with huge number of misconception. Okay. Now this one, partial drawing. So we can see that the student have labeled as condensation here, and then they have living things. This one I'm not sure whether maybe it's a chicken or what, I'm not sure. And then they show evaporation, they show condensation, they show some trees. And then they have a different earth surface like a mountain and sea, sun. So partially this is correct. Nothing seems to be wrong here. Partially it's correct, but it's not complete. Okay. And then the fifth level is comprehensive representation of drawing. So these students have really talked about the whole thing about water cycle. You see the water cycle. Then you can see the cloud condense the water, then it goes to the sea. From the sea, it evaporates to the sun. So this is some sort of complete understanding of water cycle, and the students have labeled the element here appropriately. So this is done with 12 or 13 years old students. So drawing is a way to actually detect misconception. And if you use this in chemistry, for example, you want to talk about state of matter, drawing would be a very good approach to detect the misconception. Okay, so I've shown you about cartoon concept. I've shown you a drawing, which is for younger students or young learners and early high school. We have in Malaysia, we have different category of high school. This one is done when the people just join the high school. Okay, another approach is interview. You see, just now I said concept map and drawing. We also, during when the student draw or when we show the cartoon concept, we actually encourage them to answer questions. We ask them questions, then we expect them to respond, so that they can focus on the diagram, they can focus on the concept cartoon ataupun the diagram that they are drawing. So this one just to prompt them to think. Okay, so we didn't do the concept cartoon alone, but we have combined concept cartoon with the questioning. So the questioning, some articles says as an interview. Okay, so combination of concept cartoon and interview, combination of drawing and interview works well as well. Okay, but interview alone itself also a good source of identifying a misconception. Okay, so in fact, some studies say that one of the best and most widely used technique to find out knowledge and possible misconception. Okay, so you must remember. But if you want to use interview for identifying misconception, you cannot simply ask questions to assess their understanding. The question, you cannot simply say that, okay, you ask a question, you expect them to answer, then from there you just want to know whether they can answer properly or they are answer incorrectly. The question cannot be like that. If they answer incorrectly, you have to pose prompting question. Okay, you have to prompt until you can come to a conclusion that this is a misconception. It's not that they do not know the answer, but they are conceiving the concept that you are assessing in a different manner. Okay, so interview is the best approach. In fact, if you ask me, a study, you see, like there are many kind of instruments suggested by researchers. We have 1 tier, 2 tier, 3 tier, 4 tiers, and all that. I will explain to you later. But this kind of instrument is actually developed in the literature for the use of in their own countries, in the country that which is developed. Like most of the instrument developed by Tregas, maybe it is appropriate for Australian context. But if you want to use in Indonesian context or Malaysian context, probably the content wise is not appropriate. We need to do some modification. But then if you are doing an interview, you're very much basing on your context. So interview is a very good approach to identify the misconception. But one problem with the interview is you have to know how you should ask questions so that you're not only identifying their understanding, you're not extracting their understanding, but at the same time, you are also knowing that whatever the students giving the wrong answers from the students are misconception. So you have to trigger, prompt them to answer with many questions until you come to a conclusion that whatever they have is misconception. So in order for you to do this, you need to have a prior knowledge. What are the misconceptions in the area that you are investigating? So based on your reading of literature, you have, as a researcher, you already have some kind of knowledge. Okay, these are the possible misconceptions that students can have from the lesson on chemical bonding. So you already have a list of misconceptions. So you ask your students, then you might want to say whether the misconception stated in the literature is also found in your context, or maybe some other new misconceptions that you have found. So these are the good way of identifying misconception interview. And if you are targeting for publication in good journal, rather than using very established diagnostic instrument, using interview questions will be the best, because it's very much context specific. Okay, but the constraint is you need a large amount of time. It's not like administrating a diagnostic tool. You just administer, you get the answers, you analyze. That is very fast. But for interview, it takes a long time. And then the researcher need to be trained in terms of how to ask question so that the question actually can detect misconception. Okay, so that is some drawback of what you call that interview. But some researchers say that if we can combine interview and multiple choice question, that will be a great, or diagnostic instrument, that will be very good way of identifying misconception, because interview alone takes a very long time, and it puts a heavy load on the researcher. So we can make do with having some interview and what you call that, combined with the research instrument. So like for one example that I would like to share, like when I did the study on students' misconception on global warming, I want to know what they understand about global warming. I mean, this is a common misconception. Everybody thinks global warming is something that increases the temperature of the earth. That's all we know, but it's more than that. So when I asked the students, what do you understand about global warming? They said global warming is the increase of global temperature. The hot climate is due to global warming. I think it is because the increase of temperature. The hot climate, less rain and dry outside there. So this one is partially correct. But most of them, they literally say that it is about increasing the temperature. So this is response from student 1. This is another student, a different students answer that I have put in here. So what are the misconceptions? Students tend to link global warming to the increased temperature, and a more sophisticated understanding of global warming is what they are actually experiencing in their real life, like flooding, drought, landslide, and so on. So these are the most sophisticated kind of answer that we expect from the student when we ask about what is global warming. So this is one example of interview question and interview responses. So usually those days when we don't have this 1 tier, 2 tier, 2 tier, 3 tier instruments, a lot of studies are done based using interview approach. Okay, interview approach. But nowadays people want, we want to go easy way. The instruments are already there. We try to use the instrument. Okay. Okay, so interview is another way of detecting misconception. Now, just now I mentioned, right, using interview alone, probably you might create a lot of loophole where when you publish your article or your thesis is reviewed by a panel, then they can ask you, how can you ensure that these are the misconception? How sure are you these are really misconception? But when you combine interview with the diagnostic tool, then you can ascertain, okay, this the one I identified in the interview are actually misconceptions. Okay, now there are few diagnostic tests. Okay, so I will talk to you briefly about 2 tier, 3 tier, and 4 tier diagnostic tests. Initially, before going into 2 tier, many studies have used multiple choice question. That means you have your question, you have a choice A, B, C, D, or E. So you just have to choose one of the best answers that reflecting your understanding. So this has been going on. But then, if you're just using a multiple choice question, I can question you. How sure are you the wrong answers are misconception? It's not actually reflecting the students not knowing. We cannot say when the student give wrong answer, it is misconception. Probably they do not know. Probably they would have simply guessed from A to E. They simply have guessed one of the answers and they pick that answer. So multiple choice is not a good way of identifying misconception. So what happens? People have started to come out with 2-tier diagnostic instrument. Okay, 2-tier diagnostic instrument. The first tier is the multiple choice question. Okay, you have to have a choice A, B, C, D. Then the third tier will be how sure are you, or you need to explain why your choice is A or why your choice is B. You need to give explanation. So for example, so this is an example. So in the following 2 experiments, you would expect the bulb in the experiment 1 to light up. Okay, you have experiment 1, you have experiment 2. So the first one is true or false. If you choose your answer as true, you need to why your answer is true. Okay, so you have given 4 choice. So if your answer is false, you need to say why it is false. Okay, so you have to choose A or B and then you find reason. So this is 2-tier instrument. So 2-tier instrument, so when people design two-tier instrument, you see here there are four choices here. Tetrachloromethane contains more ions. Tetrachloromethane is a covalent compound. Hydrochloric acid consists of free moving ions. Hydrochloric acid reacts with carbon electrodes to complete the circuit. So you see here, these four statements here, it's not that the researcher simply put, okay, it's not that they simply come up with certain ideas and simply put, but they have done a complete research, few stages of study to detect what kind of misconceptions students have. Frequently student will carry while learning about electrolysis, about electrode and non-electrode. Electrolyte and non-electrolyte. So what kind of misconception student always carry? So they did a few stages of studies. From that studies, they have find out that commonly student perceive tetrachloromethane contains ions, but tetrachloromethane is a molecule, there's no ion. Tetrachloromethane is a covalent compound. Students tend to believe, but tetrachloromethane is not a covalent, so intact compound molecule. You know, hydrochloric acid reacts with carbon electrodes. Can hydrochloric acid react with carbon electrodes? So these are the kind of misconception, wrong thing that students always carry with them. So from there, they identified. All these are identified from the past research. So when they develop the diagnostic instrument, say they have included all these answers as distractors. So you see, the answer 3 is the correct answer, but 1, 2, 4 are distractors. So the answers which shows that they are having misconception, the distractors. Okay, so if you're doing an interview, from your reading about electrolysis, you already know student always carry the misconception tetrachloromethane ions. Student carries misconception tetrachloromethane is a covalent compound. So let's say you're doing an interview. So when you ask the student about give me an example of good electrolyte or a non-electrolyte. So the student will say, okay, tetrachloromethane is not electrolyte. So you might want to know why. So if they give the answer like, you know, it contains ions, it's a covalent compound, then it shows that it carries misconception. So that's why I said your reading of literature is very important. Whatever misconception stated in the literature, you will try to trace them in the interview. Okay, so this is a kind of two-tier instrument. Why two-tier question? Because you have first tier, which is true or false. You need to decide whether the answer is true or false. Then after that, you need to choose 1, 2, 3, 4 in the given form, which is the correct explanation for your choice. Okay, now sometimes we don't really have 1, 2, 3, 4, the choice. We don't give the students to choose, but what we give is we give an open statement. Can you explain the reason for your answer in for opting for A or B? So when you give open statement, the student will write why they choose A or why they choose B. So from there, you can actually try to trace whether this kind of answers, the students tend to give this kind of answers or not. So if they write this kind of answers, it shows that they are having misconception. Okay, so I hope I'm clear now. Right now, so even two-tier, after some advocates of misconception say two-tier is not actually a good instrument because you are giving an option, you are giving 4 options, so probably student can guess the answer. That means, you see, tetrachloro contains more ions. Tetrachloromethane is a covalent compound. So you see, the response 1 and 2 is somehow connected. If it contains ion, it cannot be a covalent compound. You know, but if it's a covalent compound, it cannot be an ion. So that it shows that the two answers are definitely not right. You can actually try to connect the answers and guess your answer. Tetrachloromethane contains more ions. If this is correct, the option 2 definitely is not correct because it says it's a covalent. How can ion present in the covalent compound? So some researchers say when we are giving few options, we are giving options for the students to choose their reason. There are possibility for them to actually use the option to guess, or use the options to make sense of their understanding. So they said two-tier is not really a good way of identifying misconception. We need to have 3 tiers. We need to add one more tier so that we can be very sure that whatever the students having, whether it's a correct understanding or really misconception. Okay, so that's why I've presented here students' reasons linked to the answers related to misconception. So even though it is a practical way, it is used in large scale, ease of scoring, giving explanation, reducing guesses, and but whatever it is not it is not well, it is commonly used, but there are also critics on two-tier. So the critics that, as I said, they find, the student find from the option given, they try to link and find the new answers. Okay, right. To overcome this, 3-tier test was invented. Okay, so 3-tier test, the only difference from 2-tier is you have your first tier, which is A, B, C. You can have A, B or A, B, C or A, B, D or whatever it is your option. Then you have 1.2. You give reason for the choice in the earlier tier, first tier. And then the last tier, the 3rd tier, are you sure about your answers for the previous 2 questions? So if I'm sure, so let's say this one. So if the students have give correct answers and they say they are very sure, that means they are having correct understanding. They are having a wrong answer, but at the same time, they're saying, I'm sure, it shows a kind of misconception. So the degree of agreement, okay, 1.3, the 3rd tier is actually shows the degree of agreement to the first 2 tiers. Right. So based on the degree of agreement, the students can, the researcher can see whether it's really a misconception or the students really don't know the answer. Okay. So this is one example of a 3-tier instrument. So usually the 3rd tier is only measures the degree of agreement. So that's why I put here. It's a where I put it's a degree of agreement. So all the time it only measures to what extent they are sure or not sure about their answers. Okay, but again, there is a problem here. When you ask, are you sure about your answers for the previous 2 questions? Maybe the student might be sure for the first tier, and maybe the student might be sure for the 2nd tier. But this question, the 3rd question, are you sure about the answers for previous 2 questions? When I say I'm sure, probably it reflects the first tier, and then the 2nd tier, I might not be sure. But because I'm sure about the first tier, I said I'm sure. So this is also created some kind of we can question the validity of the instrument. So when I say I'm sure, which is I'm sure about. Am I sure about 1.1 or am I sure about 1.2? I might not sure about this, but I think I can answer. I am quite sure about 1.2, but how to choose the answer? So there is some kind of disagreement here. Okay, right. For that reason, people started to come out with 4 tiers. Okay, now I have also read many articles on 4 tiers. There are many ways of people designing 4 tier question, but I am not going to. I want to stick to the 4 tier instruments which has been published in renowned journals like Research in Science Education, maybe a Journal of Research, a Journal of Research in Teaching Science, JRST, and all that. If you look at more ordinary journals, we can really question the validity of the instrument. So I'm not referring to them, because there are many ways people have presented 4 tiers. So I don't trust this kind of research, but the one I show you is a very valid research. So I prefer looking and sharing information, the research which I think is very valid. Okay, so for 4 tier, you see, you have your first tier question, and then you rate your confidence from 1 to 6. Then for the third tier, you ask reason for the answer in the first tier. Okay, you have your first question, okay, first tier question, then you rate your confidence from 1 to 6. And then your third tier is reason for the answer in the first tier. So you have 5 or 4 options. You ask the reason. Why are you saying frequency, or why are you saying it's a period, or why are you saying it's a wavelength? And then again, you ask the students for the confidence. That means whether are you confident with your answer? To what level are you confident with your answers? So compared to tier 3, you see, in this tier, the confidence is asked at the last. And here, the researcher are not sure whether the confidence is expressed for tier 2 or tier 1, it collectively. But in tier 4, you can see that the confidence is 4 tier questions. After each tier, there is a confidence rating. After each tier, there is a confidence rating. So this is the reason why it is called 4 tiers. So far, there are not many 4 tier instruments. So this is one of the 4 tier instrument that I think it's a really good instrument for the wavelength, study on the wave. Okay, so these are 3 tiers, tier 2 tier, 3 tier, and 4 tiers. So 3 different tiers that people frequently use in the study, in the research, to measure misconception, to identify misconception. So if you see, these questions are differ from the multiple choice question. So let's see what other people, more explicit instrument. I will go quite fast, so you bear with me here. Chemical bonding. So this was first introduced by Tan and Tregas in 1999. So they did an interview, actually. They did an interview. From the interview, they identified that students have a problem, or they have misconception on bonding and lattice and intermolecular forces. Bonding. So these are the kind of misconception that students carry. So from this, the interview responses has actually brought them to the questionnaire on misconception. Okay, right. So for the first item, sodium chloride exists as a molecule. So it's true or false. Then the reason. So this is a simple 2-tier instrument. So in this instrument, in this item, it measures that bonding as well as the lattice. It measures the bonding, the understanding about bonding as well as the lattice. So first thing is, you need to know whether it is a molecule. Do you agree sodium chloride is a molecule? If it's a molecule, then why are you saying it's a molecule? If it's not a molecule, why it's not a molecule? Okay. Then silicon carbide has a high melting point. This one is got to do with intermolecular forces because silicon carbide is a macromolecule. So if you say it is high melting point, then you have to say why it is a high melting point. As high melting point, high boiling point. This information suggests that the bonds in the silicon carbide are, so because it has a high melting point, high boiling point, the bonds are is the bond strong or is the number of bonds are more? Okay, so whether it's weak or strong. So if you say weak, why? If you say strong, why? Okay, so we have about 9 items here. So the 9 items measures students' understanding or misconception on bonding. So these questions are specifically designed to measure the misconception on, like question 1 on bonding and lattice, question 2 lattice and intermolecular forces, question 3 on bonding. So this is on element C. They have given you the configuration, and element D, E react to form an ionic compound, Ce, true or false. So you can see here 2, the valence is 2, here the valence is 7. So one is a non-metal, another one is metal. So you can see this is group 7, this is group 2. So definitely it is the ionic bonding. Then if it's ionic bonding, why? Okay, it's about bonding. So similarly, you have questions on each and every misconceptions that they have actually, they feel they have find out from the literature, from the interview, and they have designed this question. So when we conduct this study, you know, all these things, later I will share the full article with Dr. Nurma, and you can have access to the questionnaire as well. So from our own study, we find out that sodium chloride is not a molecule because sodium donates the electron to chlorine atom, and sodium ion forms a molecule with the chlorine ion. See, B2 is the misconceptions the students, most of my students had, that 54% of the students. So that means, let's see, B2, that means it's not a molecule. So, sorry. Yeah, it's not a molecule. So sodium chloride exists as a molecule. So the student said false. It's not a molecule. And then the reason is B2. That means they have opted for B and 2. After donating its valence electron to the chlorine atom, the sodium ion forms a molecule. So the answer is molecule. So most of them said they have the misconception that sodium chloride is a molecule because it donates electron to chlorine atom and forms a molecule with the chloride ion. So this is the misconception that 54% of my students carry. So I hope you can follow me. Now for question 2, 49% of them say that B3. Let's see what is B3. B3 is B. Sorry. Okay. Oh, some mistake here. I don't know what's the mistake. Where the 3 comes from, I'm not sure. So it should be 49% say that B3. Yeah, B3. Right. So B is I did some changes here. That's why. Okay. B, they agree it is okay, there's some mistake here. I think combination of responses. So a molecule is composed of covalently bonded molecules. A macromolecule composed of covalently bonded molecules. So we can see here in the B, silicon carbide is a macromolecule composed of covalently bonded atoms. So the word atom, the word atom. So it shows that they have the misconception. Okay. Similarly, what we have found in our study is these are the range of misconception that we have actually identified in our study. That is on chemical bonding. The second questionnaire that I would like to introduce is two-tier multiple choice diagnostic instrument to measure misconception on electrolysis. So I have to stop sharing and I'll show you the word file because the instrument is too large. I can't actually show that in this one. Let me show the word file. Give me a second.
Ya, adik-adik, mahasiswa, teman-teman mahasiswa, kalau misalnya pas ada pertanyaan, pas keinget apa gitu, ditulis langsung di chat ya. Jadi tadi ada beberapa hal yang sudah dibahas mengenai miskonsepsi dan instrumennya.
Hold on. Okay.
Okay.
Hold on. I'm showing. Can you? This is the wrong one. So I know I will have trouble here.
Okay.
Hold on.
Jangan lupa ngisi persensinya ya untuk semuanya nanti untuk record kita di panitiaan. Termasuk nanti ada sertifikat untuk 4 kali pertemuan.
Oh, okay, fine. Okay, can you see this?
Yes. Now
Okay.
PDF, right?
Yeah, PDF,
Yeah.
PDF.
Mm-hmm.
Right. So this is an example of a question on electrolysis. So just now I showed you two-tier, right? So one is the example, I took it from here. So the first one, the question measured on whether the students can differentiate between electrolyte and non-electrolyte. So the first question, the electrolyte is hydrochloric acid, non-electrolyte is tetrachloromethane. So whether they can differentiate between electrolyte and non-electrolyte. The second question is electrolysis of molten substance and then gases. Electrolysis of molten compound and what is the product. So the question is, during electrolysis, reddish fumes of bromine gas, molten lead are produced. Oxidization occurs at the cathode, true or false. And then what is the choice? So if you give an answer false and then 2, this is the correct answer. But if you give answer true and then you have choose between 1, 3, and 4, that shows it's a misconception. Okay, so these are examples on electrolysis. Similarly, in the manufacture of chlorine by electrolysis of concentrated aqueous, this actually measures the product of aqueous electrolysis. So when you do electrolysis of aqueous solution, what are the ions discharged at the cathode and anode? So see, we have about 17 items in this questionnaire. It's a two-tier instrument which actually measures the concept of electrolysis. So this one also later I will share with Dr. Nurma. If you want to use, it's not my instrument because it is openly available. I think you can simply take and use it unless the author requests you to write to them or what. But this is openly available, and I have actually used this instrument in many of my studies. Okay.
Yeah. This is from SIA, yeah, Dr. Mages?
Yes.
Yeah. All right.
Right. So this is one of it. Like, let me close this. I'll share another one. So this is the one on the chemical bonding, Tan and Tregas. So you can have the instrument here. So, but in my study, actually, I didn't use Tan and Tregas at all, totally on them, but I mix it with Osman from Turkey.
Yeah,
so
Osman.
to measure the misconception, right? Right. So I hope you can get the idea, electrolysis and bonding. Now I go to another one, which is on acid base. Okay. Okay. Can you see this? I'm showing acid base now.
Yes.
Can
yeah. But
yeah,
you can try to zoom in, Dr. Marquez, with the plus this one. Yeah. Yes, that's enough.
Okay. So this one is so for example, it is, let's go through the question. Chemical X shows the following properties, blah, 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 blah. Which of the following is the most probably chemical X? So that means you need to detect based on the property whether chemical X is the base or acid, right? And then you need to give this answer. So that means it's a two-tier instrument. So there is a first tier and then second tier. So the first tier instrument, you can have ABC, ABCD, it depends on you. And then the second tier also, you can have few choice and also you can give reason. So the first tier, basically, you need to talk about whether you access students' understanding of the property of acid and the property of base. Whether students have misconception in differentiating the properties of acid and bases. Okay. The second one is about the table shows the values of 4 solution pH value. So here you are measuring the understanding or misconception relating to pH value. What are the pH value of the acid and what are the pH value of the base and the strong acid and weak acid? You know, so you have to give the answer in terms of concentration of hydroxyl ions and hydrogen ions. Okay, right. So this questionnaire is done for Malaysian students for 16 years students. 16 years is the students learn chemistry for the first time. Chemistry as a separate subject for the first time. So they learn about basic properties of acid and base. You know, so we want to measure whether they want to really they understand the properties of, they have any misconception on the properties of the pH values and acid and base. Okay. Now, what is the main apparatus that is used in preparation of standard solution? So you are giving here volumetric flask, beaker, and measuring cylinder. So the reason, you have to say why. What is the reason? So here we are talking about how to prepare a standard solution. So most of the time we don't do this in the lab. So nowadays, like this kind of misconception, when I conduct the study, this kind of misconception is very common during the COVID time, because we did the lesson online. So how they know how to prepare standard solution, you know? So why you use volumetric flask, why use beaker, or why you use cylinder? If you said volumetric flask, why it is that? Okay, so there's answers for this also. And also we give them option for right, the reason, what would be the best, why are you saying the answer is as such. So both sulfuric acid and ethanoic acid are strong acid. Is it true? True. Why? False. Why? So we are expecting them to describe whether it's a weak acid or false acid from the perspective of concentration of hydrogen ion and concentration of hydroxyl ions. Okay, so this is the instrument to measure acid and base. So two common substances that have the formulas of HCl and CH4. Both contain the element hydrogen. However, only HCl has acidic properties while CH4 does not. Why? You know, so we know HCl can be dissociate into H positive and Cl negative. But then methane is not possible. Right? Right. Why? So comprises our ion, it is a molecule, you know, so that kind of reason. So what is the property of citrus fruit, oranges, and lemons? So this is a simple questionnaire to measure the students' understanding about a fundamental understanding about acid and base. Okay, and probably this questionnaire is if you use this questionnaire and try to write for high impact factor journals, probably we won't succeed, because it's a very simple questionnaire to assess acid and base. You need to have more advanced question. You have to assess students' understanding more advanced conception of acid and base, rather than simple questions like this. Okay, so this is on acid and base. So let me see what else I have. This is the one. Okay. Okay, I think I have shared the questionnaire. Let me stop sharing and get back to another one. Hold on, give me some time. Do you have any question before I get for the other questions? Yeah.
Thank you, Dr. Mages. We have one question from Satria Aji. Aji, you want to directly speak to Dr. Mages? Please, if you want. You are at school, right? Aji, can you hear me? Okay, yes. Because now Aji is also chemistry teachers at one of Islamic high school in Surakarta. He asked about, saya ingin bertanya, bagaimana kita bisa memastikan bahwa jawaban dari pertanyaan itu setara. Apakah jawaban dari tier pertama soal tidak akan mempengaruhi kesetaraan jawaban di tier kedua dan sebaliknya? Understand, Dr. Mages? Or I should?
Yeah, I think you should translate.
Oh yeah, okay. So good afternoon. I would like to ask how we can make sure that the answer is in a balance, setara. What is the means? In the same.
Yeah, setara. I paham setara.
Yeah, setara.
Okay.
And how if the answer in the first year is not affecting the kesetaraan, the answer from tier 2 or vice versa. Okay. Yeah,
now, okay, I want to know, I understand what is the meaning of setara. Setara, saya faham. That means you want to make sure, I know what's the meaning of setara, but I don't understand what the student meant by setara in this context, in the question.
I think that he asked not about the students, but setara, it means that maybe level of difficulties or
okay.
You can confirming if I'm wrong. Okay, yeah, he asked, he said yes.
Level of difficulty.
Yeah, or level of difficulties or other. So it means that tier 1 and tier 2 is in the same level of difficulties or level of discriminant item, or it means like that.
I understand that. Okay, like if you are using a standard questionnaire, like what a diagnostic test, like what I have shown here just now, all these are very established questionnaire. Okay, very established instrument. So people have already used it, and people have already said that a very good instrument. It is produced, it is developed in a very concise manner, whereby they have taken into consideration all this the difficulty level and all that. Okay, so you no need to worry about that, because that are the standard questionnaire. Again, that's why I mentioned just now, these are the standard questionnaire. But when you take this questionnaire and when you implement in your context, you will have problem. So probably, like for instance, let's say we are talking about the questionnaire by this question. Hold on, because I opened too many files. Now I got confused.
All right.
Okay.
Nanti di klarifikasi di chat ya Aji kalau misalnya ada yang belum sesuai ya.
Okay, so
Okay,
let's
that's
say
it.
this.
Chemical
Yeah,
contents.
this first question. Sodium chloride exists as a molecule. If you ask me, for my student, in my classroom, that means in my school, my students are high performing students. Okay, high performing students. They all know sodium is an ionic substance. Sodium chloride is an ionic substance. It has both sodium ion and sodium chloride. So for them, probably this question is not a difficult question. But if I ask a school where the school is the poorly performing school, it's a very simple question actually for a high school student. But low performing school, if I ask this question, probably for them this is a difficult question. So whether it is the level of difficulty, it depends on where you are conducting the study. You know, you as a teacher, you know where, the students' performance level. So that's why I want to measure students' chemical bonding, misconception on chemical bonding. Probably I won't use all these 9 items from Tan and Tregas because I feel this question is too simple. I might use Osman, another person. He also have some questions on chemical bonding. So I actually compared and contrast these Tan and Tregas and Osman, and I selected few items from here and there, right? So that in that way you can actually maintain the difficulty level. And that is one answer for that question. Another answer is, you see, sodium chloride exists as a molecule. This is a very simple question. The reason here, probably sustaining the difficulty level between the first tier and then second tier. So when these people prepared this question, they have actually considered all these constraints. If we ask the first level question in a simple manner, and then the second level question in a more difficult manner, probably the students will encounter difficulty in responding to the first tier, because the first tier might be wrong, but then the second tier is incorrect because the level of difficulty is higher. But then before they come to this level, the researchers have already conducted interviews. From the interviews, they identified these are some kind of misconception that students always carry with them. You know, so the interview responses which has been conducted earlier shows that these answers, the choice is not simply made by the researcher, but it is based on what the students have said in the interview responses. So in a way, what I'm trying to say is the difficulty level has been balanced. It's not out of something that the researcher want to say. It's based on what the student themselves have said in the interview responses. I think I answered the question. Yeah, because I look at the question in two perspectives. One perspective, the student's perspective, where you can actually think about whether to include the question or not to include, because you know your students best. Like for me, when I conducted the study, maybe the question 1 I don't want to include because it's too simple. You know, like just now, Sia's electrolysis questionnaire, tetrachloromethane and hydrochloric acid. It's a very simple question. I think all my students know how to answer, so I might not want to include that. That is from the student's perspective. But from the question perspective, whether the question tier 1 and tier 2 are balanced in terms of the difficulty level, because when the people come up with these instrument, they did the interviews first. So the distractors, you know, the ABCD, the distractors are actually from the students' responses itself. It's not that they have actually came from their own understanding. Okay, I think I answered the question. Right. That's why, like people like us, when we want to do research on misconception, I would prefer to do a interview, and then I verify whether it is misconception or not. Because these instruments are actually developed by other researchers for their own context, considering the students of their own. Okay, so this is the answer. Now let me share one more instrument with you before. Okay, can you see this one, kinetic particle theory?
Yeah.
Okay, so kinetic particle theory of matter. So this is also Tragas, but I worked with him in developing this question. So if you see here, the diagram represents the random zigzag movement of smoke particles, referred to Brownian motion, when smoke in a glass container is viewed under a microscope. So this is the diagram. What conclusion can you make from this observation? So A, B, C, D. So students can choose smoke particles are floating in the air. Air consists of mainly empty space. Air is made up of tiny particles moving randomly. Smoke particles are larger than the air particles. So first level is we conducted interview, and then these are the kind of answers we got. Students have various responses, and then when we prompt them to answer, these are the kind of answers that the students have provided. So from here we can actually say this is actually the difficulty level is for that particular group of students. There's no issue here, and the difficulty level of tier 1 and tier 2 is also almost the same. That's not an issue, right? So kinetic particle theory, the first question tested on the Brownian motion.
Sepertinya terputus ya, Dr. Makis ya?
Oh, tak dengar? Can you hear me now? Oh my God. Dr. Suzy, can you hear?
Your connection is stable, Dr. Nehal.
Dr. Suzy, can you hear?
Mr. Nurma connection.
Mr. Nurma.
Oops. Okay, students can hear me, right? Boleh dengar ke?
Sorry, I lost my connection.
Yeah.
Okay, Dr. Makis.
Can you hear me now?
Yes.
Yeah, so just now I was talking about the Brownian motion. You heard that? Oh, hilang lagi.
No.
Okay. Yeah. I was talking about Brownian motion. Yeah. So this question particularly focused, specifically we focused on measuring students' understanding about the random movement of particles in the air. So we have this collection of options, and then students have to choose what would be the best reason for the answers. Okay. The second one, we give them an example how the liquid bromine we placed at the bottom of the jar. After some time, the whole of the jar is filled with the reddish brown color. So the student have to identify why the whole jar is filled with the color reddish brown. What are the possible observation, and explain. Okay, right. So, and then we talk about volume, the properties of liquid and gases in terms of volume. So the volume, when we fill the liquid into a jar, the volume, the liquid follows the shape of the jar. So the volume of the liquid follows actually according to the shape of the jar. So we want to find out the gases also same thing, but not for the solid, right? So this question actually assess the student's understanding of that, right? So this one got to do with the pressure. Okay, when you have a pressure in the liquid, you apply pressure to the gas, what happens? It is condensed, and the students have to talk about movement of particles when pressure is applied to the gas. Okay, so same thing. This is also same thing. What happens? You apply the pressure and you release the pressure. So it's all on the movement of atoms. Right. So here we place the ink at the bottom and then water on top, and we ask the student to see what happens after some time. You will realize that the water will be colored. We place the red ink, the water will be red in color. If we place the blue ink, the water will be blue in color. So what is the reason? So this is also actually about diffusion, movement of particles between water molecules. Okay, so these are the examples of question. I think we had 10 or 11 questions. So I have also a paper published on this in SERP, Chemistry Education Research and Practice. Okay, so this is on kinetic particle theory of matter. So if you have any questions on these instruments, you can always approach me. I can guide you on how to go about it. Okay, right. Now I want to show one more question, which is on climate change. Climate change. Let me stop sharing because that is in the Word file. Hold on, let me open first.
Dr. Mages?
Yeah.
Our class until 12:50, yeah?
Until what time?
12:50.
50.
Yeah, 50. Yes.
Oh, it's okay. So I will try to.
15 minutes.
Okay. I will just go through first, and then
yeah.
I'm not sure whether I would be able to touch on the conceptual. This thing takes time.
Yeah.
Okay.
We still have time. Don't worry.
Okay. So can you see this?
Yes. Global warming.
So
Arab did.
Arab did. So this is a very established questionnaire on climate change. So if you want this questionnaire also, I can share because currently I'm doing the study now. So we have tier 1, global warming. Students have to choose A and B, and tier 2 they have to find the reason, and then tier 3 here we are having 3 tiers. Yes or no. They have to what extent they are confident with the answer, yes or no. And then similarly, we have few questions on global warming, and then few questions on greenhouse effect, and then we have questions on acid rain, and what you call that, ozone layer depletion. So in this questionnaire, if I'm not mistaken, we have about 13 questions, 13 or 11, 13 questions. Yeah, 13 questions, and these questions are divided into global warming, greenhouse effect, ozone layer depletion, and acid rain. So this is a 3-tier instrument. So I can share the instrument with you as well. And then the original author, who the author is from. Okay, right. So these are some examples of questionnaire. Maybe next week when I talk about the treatment, I also will share with you how to do some analysis, how to use the instrument, and how we can analyze the finding. Okay, so that's why actually I wanted to show through the PowerPoint, but I don't know whether I will have a time. But one more, just few seconds. few
We
seconds.
still have one question, Dr. Mages. One question from student.
Yeah, can.
This is from Mas Umam. Mas Umam is also a chemistry teachers in Sulawesi Island. Yeah, he asked about when we have already used 3-tier diagnostic test, is it do we need interview for analysis the data?
That's why as I said earlier, definitely the 3-tier instrument is from somewhere else, right? Right, the 3-tier instrument is from somewhere else. Somebody have developed the instrument. Probably it's not for the Indonesian context, but when you have the interview, that will support, that will give you a very concrete evidence that responses are actually from your students. Because this 3-tier is like this, whatever I showed, electron CS questionnaire is developed for Malaysian context. The acid-base is Malaysian context. How do you know that the same misconception can happen in the Indonesian context? So one way is to do interview. Okay, so that will give an additional point for you. Okay, right. So let me just a few minutes. I would like to go through the conceptual change model, and maybe next week I'll go very deep, but just to give you an a view, So conceptual change model. Posner, from Posner, I also will share the article. Posner is the first person in 1982. He proposed, people have been talking about conceptual change from early stage, even before 1982. But Posner, he created a 4 steps, or sometimes people say 4 phases, how conceptual change can take place. The first phase is the students must be dissatisfied with the existing idea. So if they have some understanding, prior understanding, which they carry to the classroom, he must have the feeling of dissatisfied. So when the teacher teach in the classroom, the teaching must create the sense of dissatisfaction. Okay. So once the students are dissatisfied, teacher is giving new ideas. Okay. So the new idea must be presented in an intelligible way. So it must be understandable, So that means you can use representation, or you can use many ways in presenting the new ideas, so it is easily understandable. So for students, when they see the new idea, they must have the feeling, oh, I can understand. It is easily understandable. So if they can have this sense, then it will kind of create a dissatisfaction with the existing one. So the existing knowledge, they have the sense that something not right, something tak betul. But when you use the new idea is presented in an understandable way, so it makes the students easily understandable. So it creates a kind of conflict, and then the teacher continue teaching. The new idea is plausible. It makes the students like, oh, I think I can trust the new idea. The new idea is something which trustable. I can believe the knowledge. It is something very I believe it works. Then the final thing is the new idea is fruitful when they apply in their real world, in their real context, in their real life, they feel it is working. So conceptual change happens if these 4 phases are fulfilled. So first thing is you have to create the dissatisfaction. The new knowledge that the teachers producing in the classroom is understandable, intelligible, and it is plausible. That means it is very meaningful for the student. It is believable. They can trust the knowledge. And the fourth is it is fruitful. That means you take the knowledge, when you apply it in your surrounding, they really can relate. So it's fruitful. So in order for the conceptual change to take place, these are the 4 stages, 4 phases. So when you design your teaching, let's say you are designing your teaching using 5E, or sometimes people use social constructivism, 5E. There are many theories, situated learning theory, So let's say you are designing some kind of intervention. So you must make sure that your intervention that you are designing, the teaching that you are designing, must the students able to go through the four phases. If the students able to go through these four phases, then only the misconception can be reduced or eradicated. If you simply doing a constructivist teaching without actually explicitly telling the four phases, probably the misconception will be retained. There's no evidence that misconception has been addressed. Okay, so I think it's time's up. I will go very detailed on this. I will introduce again the model, and I will show some examples of my teaching where we have reduced, we have used kinetic particle theory of matter, the instrument, and we designed the teaching based on these four stages, and we have succeeded in reducing the misconception. Okay, that one I'll show you some examples next week. Like chemical bonding, we have used computer assisted teaching instruction to reduce the misconception. And I actually didn't show you chemical equilibrium. I also have questionnaire on chemical equilibrium. So my student had done, my PhD student, she has used PHET, physical PHET, physical education technology or something. I forgot already. So next week I will show you. Actually, this PHET is available in the you can Google and find out. There is a software prepared by University of Colorado, if I'm not mistaken. So we have used that, and we have presented it in a way that he satisfied the four phases of conceptual change model to address the misconception on chemical equilibrium. Okay, so I think I'm done. I will share all the instrument with Dr. Nurma, and you can share with your students.
Yes.
Yeah. So
okay. Thank you very much, Dr. Marquez. We still have 5 minutes if you want to.
Okay.
No, five. Now in my time is 12:45, so we have still 5 minutes to have a question and answer from the students. Yeah, Dr. Marquez, is okay?
Yeah, can.
Okay, yeah. Please, anyone who would like to give additional questions? Mas Aji, Mas Umam has already asked about the instrument to diagnose the first tier problems, the second tier problem, and also how about the need to do the interview, because I'm sure that this is good ya Mas Umam. Jika nanti ditambah interview, itu nanti justru akan menggali yang tidak ada di dalam tier tersebut. Silakan dari 2020 ada pertanyaan untuk nanti. Tadi ada beberapa, ada chemical bonding ya, kemudian ada apa tadi? Ada chemical bonding, ada elektrolisis, kemudian ada asam dan asam basa, kemudian tadi teori kinetik. Silakan, ada pertanyaan untuk Dr. Marquez.
Dr. Marquez.
Yeah.
Okay.
Go back on the first topic about drawing that can eradicate misconception. I am really interested. I just want to ask about that. Do students have to pass each level one by one, or maybe students can go directly to a level without thinking through by one level at a time? It's my question.
Okay, can I answer that? I
Yes,
hope I hear you properly, because there is a glitch just now. but it's okay. So your question is whether they should go through level 1, level 2, level 3, level 4, level 5, or how. Now, you see, when we did the study, we want to categorize the student. It's not going level 1, 2, 3, 4. We want to know whether the students are having misconception on motorcycle. So we asked the students to draw the water cycle, because this is a lower secondary student. Probably they cannot explain. We asked them to draw the water cycle. From the drawing, we had about 50 over students. We analyzed the 50 over drawings. And then the drawings, we group them into level 1, level 2, level 3, level 4, level 5. So the one with the level 1, the one, just send me an empty paper with the name. There are about 4 or 5 of them. So the rest 40 over students, they have some drawing with them. That drawing, we have classified the drawing according to level 2, 3, 4, 5. So the one in level 3 is the one who carries misconception. The level 2 is incomplete. We don't know whether there is a misconception or they don't know. We cannot actually identify. But the level 3, we identified they having misconception. But the level 4, they seems to giving correct answers, but they have not given a complete answer. So they have not given a complete representation of water cycle, but they have giving correct answer. But the level 5 give us a very complete answer on water cycle. So out of 50 students, only 5 students managed to give a complete answer. There's about 10 or 11 students who have partial. They have some understanding, but that's not complete. But majority of the students gave misconception, drawings which has misconception. So what we did, we took the one with the misconception, we identify the students with the misconception, and we did the treatment. We did an inquiry-based teaching or something like that. We did a treatment and we improvised their misconception. We measured how the inquiry teaching managed to reduce the misconception. For the partial drawing, we just have to do another round of teaching to improve their understanding. That's all. It's not that they don't know. Maybe they have limited. So it's not that we have to go from level 1, level 2, level 3. It's up to you how you're going to do it. We can actually, our intention is just to see the misconception and then reduce the misconception. I hope I answered your question. Yeah. Because here the drawing is the tool to identify misconception and reduce the misconception.
Yes, very clear, Dr. Mages. Mas Gama, jelas ya?
Ya, jelas.
Jadi tadi di level 3 langsung, kemudian nanti bisa di eradicate istilahnya ya, di obati, di cure untuk miskonsepsinya. Dr. Mages, we already reached 12:50 now. So this is the end of the second meeting of our class. Do you want to share something about the things that they have to learn or they have to read before the upcoming meeting?
Oh yeah, they can read about conceptual change model. How Posner, I will share the article with you, but that article is, the level of language is very high, but that is the original article by Posner. But then after that, people have used Posner's theory in many research. So you can actually Google and read through the articles and get to know about what Posner said. And also, I would like to say, if you look at my research on misconception, I always won't simply use the instrument. I always will accompany the instrument with a qualitative measure. I always try to do mixed method. The reason is very simple. As I said, the instrument is from somewhere else, and we cannot be sure that all the misconceptions said by that people can happen in our context. That's why the qualitative is very important. That one I would like to highlight to all the students who are planning to do the research in misconception. Secondly, you see, the area in misconception is so concentrated really. It's tepu tau, tepu. So it's already so tepu. You want to come and do the same thing. Nobody wants to read. Unless you want to say in Indonesia, you have something very specific that nobody in the world knows about it. Qualitative interview only can do that.
Yeah.
If you administer the questionnaire, you cannot do that.
Mm-hmm.
That's the thing that you have to have in your mind.
Okay. Yes.
Right.
Yes. Two things from Dr. Marquez. I'm sure that this is you have to think harder for upcoming meeting for the third week of our visiting professor class. Thank you very much, Dr. Marquez, for your time. It is very insightful and then very outstanding, because even this is very concentrated, because now we are in the problematic chemistry learning. So this is still become problematic for students in chemistry classroom. That's why we, as a teacher, as a researcher, we should learn it deeper and deeper, and how to eradicate the word that I take from Dr. Marquez.
Right.
Okay, thank you, teman-teman. Thank you very much for joining this class. And also, we have also students from undergraduate. Yeah, so they want to learn more from the master students. So they just join and then try to get the knowledge and also all the things that you have already shared. Thank you very much, Dr. Marquez.
Right.
Thank you, students. See you next week at 11 o'clock. Don't forget, tadi Mas Bam lupa ya. Jadi nanti jangan lupa, ada yang lupa tadi. Ingatnya Kamis, karena kuliahnya awalnya Kamis, kita shift ke Rabu, Dr. Marquez. Ya. Oke. Selamat siang semuanya. See you next week. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, terima kasih.
Bye-bye. Thank you.
Bye-bye. So I hope it benefited the student. Right. Bye-bye.
Yes.
Bye.
Oke. Selamat kuliah untuk yang 2020 dan 2021 ya. Terima kasih yang sudah bergabung dari S1. Terima kasih semuanya.
Ya, terima kasih, Bu.
Yang terima kasih juga yang masih melihat di YouTube karena tadi sambil mengajar sepertinya. Ya.